Ladies and gentlemen, welcome for this lecture of physics, and today's topic is quantum physics. Now this is topic number 22 of Cambridge International AS and AL Physics, and before I go to the key areas to master and specific learning objectives, I'm just going to give you a hint of what quantum physics is about so that we can have a good understanding of this particular topic. Now, what is quantum physics in simple terms? Yes, quantum physics is the study of matter and energy at the most fundamental level, and it aims to uncover the properties and behaviors of the very building blocks of nature, which can be fundamental particles like electrons. Electrons can be understood to be the smallest particles, which are fundamental particles, and things like photons, which is a quantum of electromagnetic energy. So also, to make it simpler, quantum physics is just a branch of science that studies the smallest things in the universe, and it finds its use in lasers. We talk about optical fibers, light emitting diode or LEDs, and knowledge of quantum physics has enabled the invention of smartphones, ideas of quantum computing, solar panels, and GPS navigation. Who then is known to be the father of quantum physics or mechanics? One of the greatest scientists called Max Planck, who was a German theoretical physicist and discovered the idea of quantum action known as the Planck constant, is said to be the father of quantum physics. In this case, this happened in the year of 1900, whereby Max Planck gave ideas about energy quantization, and in this case, it won him a Nobel Prize in the year of 1918, and the work of Max Planck laid the foundation for the quantum theory by the great Sir Albert Einstein. So quantum mechanics is a joint work of Sir Albert Einstein, but the key idea came from Max Planck about energy quantization. So on the key areas to master and specific learning objectives, there are 4 areas. One is energy and momentum of a photon, whereby a photon is a quantum of electromagnetic energy, or just a packet of energy. By the end of this topic area, you should be able to 1. Understand that electromagnetic radiation has a particulate nature. In other words, electromagnetic radiations behave as particles. Then number 2, understand that a photon is a quantum of electromagnetic energy. The idea of Max Planck about energy quantization. Then photon energy is given by HF, whereby energy is directly proportional to the frequency. And in this case, we are going to realize that the maximum kinetic energy of the emitted photon will only depend on the frequency and not the intensity. Then another unit of energy, which is the electron volt. And here, the energy gained by an electron when accelerated by a PD of 1 volt is the electron volt. This is going to be another unit of energy aside from a joule and kilojoules and so on. Then the last part is understand that a photon has momentum, and the momentum is given by P is E over C. E is energy of a photon, C is the speed of light, which is a constant. Now the next part is about a photoelectric effect, which comes from photo meaning light. Electric effect means ejection of surface electrons by use of electromagnetic radiation. So by the end of this topic area, you should be able to understand photoelectrons may be emitted from a metal surface when it's illuminated by electromagnetic radiation. This is specific to the use of ultraviolet radiation that has the only frequency that can eject electrons from the metal surface. Then number 2, understand and use the terms threshold frequency and also threshold wavelength. At the minimum frequency below which no photoelectron is ejected, on a metal surface is the threshold frequency. So it means at threshold